All right, ladies and gentlemen, I would like to welcome you back and welcome you to the second keynote today. And as I mentioned very briefly in the introduction this morning, we do have an interaction between academia and practice. We do have the interaction regarding these two conferences we have, so the WI and the multi-conference that's taking place at the second floor above us. But we also have this interaction to practice inside our conference, and it is my pleasure to see how academic thinking is translated into practical solutions and also products in practice, and that really brings academic results to life. So that's what I really value. Now, we do have a keynoter who has learned very deep about data science. Preisach has done her master degree in computer science in Freiburg in Germany, a very nice location, as Leipzig, of course. And then she followed up with a PhD. She finished her PhD on data science at the University of Hildesheim, also a southern part of Germany, and more or less from Leipzig. And in 2010, she went to SAP and started as a data scientist at SAP, and now she's heading a team on data science at SAP with 17 people. Now, what is very exciting, she will talk about what really machine learning can bring for practice, for the application. So what are the benefits of machine learning? And I'm really excited about these solutions in the Internet of Things area.
Thank you.
Welcome, Preisach.
Thank you. Welcome to my talk. And I think I don't have to introduce anything, so I start right away. So I want to start with some examples and facts. And probably most of you are commuting or using public transportation, as we also have seen in the other talk. It's an important area, and I think there we will see a lot of things going on in the terms of IoT. So what is it about? It's really about saving time and improving life quality. So for instance, not waiting for your next train because it has broken down because of some failure of some component, which I actually experience very often. It's always saying, oh, technical problem. You have to wait for 30 minutes. So hopefully this will not be the case in the future with help of, say, predictive maintenance, where you try to predict failures in advance. So optimized traffic is one thing, which we also heard before. Less pollution, less energy consumption, or I mean more optimized energy consumption. Other examples which we, I think, also heard a bit is more on these wearables, fitness trackers. Probably many of you also have that, or your students. And you know, they're measuring body functions, but also your motion, how many steps did you do today, and also the environment, altitude, GPS, and things like that, which I think there is a market for to continue on this topic. Smart homes or connected homes, I think it's the newer term, is also coming up. And we built a house last year, so 1 year ago we moved in the new house, and we thought, you know, should we do it? Should we not do it? Should we invest in smart home? And we decided yes, we do it, because I think that is really the future. You want to have control over your house, over your heating, over your shutters, so that in the summertime you don't have a totally hot living room when you come home. And I think it's really nice to have that. It's about convenient living, but it's also about safety, because we have sensors in the house which are alerting if there is an intruder. And I think it's about both safety and convenience. I think more important, and I think this was actually the main content of the last talk, health care. And I had a checkup, I think, 3-4 weeks ago, and this doctor had time. So he was very interested about machine learning and what I'm doing and so on. And I asked him, what actually do you already do in this area? What tools do you have? What is your expectation in terms of tools and so on? And he said, actually, I have nothing. I have no automation. He was an internist. And he said he would be happy to have more help, simple things which can be automated. But I think also, actually, what I read from from several books, there happen a lot of failures. Also and I mean, the medical system doesn't want to admit that, but it's actually like that. And I think the data which is there can be used to at least assist. It's not like that yet, but what we see is, for instance, for this diabetes meters, so there are continuous meters which are measuring the blood sugar. The daughter of my neighbor has that. She's 7 years old, and she knows exactly how to control that and how to handle that. She gets alerts if the blood sugar is too low, and she knows now I have to eat something specific, or I get an alert it's too high, so I have to take care of the next meal what I do. And that's really practical. So I always see her on the street. Okay, she looks at her gadget, and then she knows what to do. Now coming more to the industrial area, so it's called industrial IoT, and that's where SAP is more looking at the moment. Or at least in my area where I am, we are looking at the industrial IoT, and here it is about really saving resources by, for instance, detecting failures. So for instance, this pipe has an obvious failure. I think this would be also obvious to detect by eye and so on, but not all failures are. But also about theft. So we have a lot of utilities companies who look at, in specific countries of the world, where theft is a real problem, of water, of electricity, and so on. And you can use similar technologies to detect that with sensors and so on. But also with resources, I mean costs and time and money. So in other areas, like in manufacturing, it's more about detecting also failures early in a production line, because you don't want that your production line stands still. This is really a lot of money which you lose if that happens. So it's about, first of all, reducing downtime or having no downtime in production. And it's also about, in general, optimizing processes. So you want to have short cycle times. You want to improve or increase the number of products you are producing in a specific time. So it's really about optimization. And also product quality. So you want to know early whether something is happening which could lead to a bad product quality. You want to know the patterns. What actually happens? So what is a pattern which belongs to some upcoming negative event in that case? And as you know, Industry 4.0 is very related to this, to manufacturing, and a lot happened there. We also heard from the minister-president of the state here. There is a lot of automation. I also saw, factories with no people. It's so strange, but it is already there. So here, the technology is very advanced, and a lot of money goes into this. Coming to a definition, Wikipedia. So it's all about the sensors, the connectivity, hardware, software, and of course the physical objects like machines, components, equipment, and so on, or our small gadgets. And you probably know, I mean, the reason why the Internet of Things really started to grow so much, and it still does, is because of the cost reduction. So now it's possible. It's easy to do. But we will see, it's not so easy. So it's still growing. I have some numbers, some facts from Gartner. So the number of devices, 2016, should have been around 6.4 billion, which then divides into two areas, consumer and industrial devices, with almost double the number of consumer devices in comparison to industrial devices, but of course much cheaper. So if you look at the money, it's completely different. It should grow further, 2020 to 20.8 billion. Actually, this number was adjusted, so it was 50 billion. If you look up the numbers a year ago or so, everybody said it's 50 billion. So I think the hype went down a bit, and now we are maybe at more realistic numbers. I have another one which I found very impressive, and I'm not sure whether it's really true. It's also a prediction. It's for 2019, 2 zettabytes. 2 zettabytes, I looked it up because in my computer science study I didn't learn that. So it stops, I think, at petabyte at that moment. So it is actually, so there was a comparison, 70,000 years of video material, which could be stored in these 2 zettabytes. And remember, it's terabyte, it's petabyte, it's exabyte, and then it's zettabyte. So it's quite a lot. So the question is then what we do with that. So that will come later. So I have another study here, which I found interesting because it's not about estimations or counting Google searches or other ways of looking how much in the different industry the IoT grows, but it's about projects. So publicly known projects. That's why consumer IoT is not included here, because there are no publicly known projects about that. Or I mean, no big projects. It's that you have your wearable and that's it. So it's what we see here is the connected industry, which is very related to manufacturing, to oil and gas, to the Industry 4.0, is the leading industry who is doing IoT, which is doing IoT projects with 22%, and then followed by smart cities, which I found actually quite surprising. But maybe I think there are many research projects also from European Union and so on where also these are counted here. So it's not necessarily always industrial projects, but with research and industry together. And then followed by smart energy, connected car. So connected car is, your car with internet access and everything what is possible with that. That could be just your entertainment system, the connection to your mobile phone, to your smartwatch. But it is also about safety, when you're tired, that you get alerted by your car, about many things. It's also about maintenance, so that you get an alert, you should go to your garage because something has happened or will happen, both. So, and then some other areas which are minor at the moment. Also the connected health, you see with 5% is not a lot. And I think this has to change. And you see from the areas that the Americas area is a bit more relevant in this area than Europe, except for the smart cities where Europe is leading. So now the question is could machine learning be a solution to the problems, challenges we have there? And that's what I want to discuss. And also look at the challenges machine learning has with IoT, both directions. So we have actually seen just previously, and I was, the same slide, the challenges in IoT. Remember the 5 V's, or there are more V's, sometimes there are 9 V's of big data. And these apply here as well. And I want to give you some examples, on the different V's from our projects. So we are doing a lot of projects with customers in completely different industries, train operators, aerospace, manufacturing, many things. So, and what we see, the first V is volume, so how to scale. And what we have seen, one of our projects in 2013 was about airplanes, and it was actually A320 or 30, and it had 4,000 sensors, which is already a lot. Of course, it has a lot of components and so on, and you would probably never use all sensor data at once for machine learning. But you use for each component then a portion of it. But now the new A380 has 40,000. And even if you just use portions of it, you have already a problem. At least if you do not have the right platform. So that's a requirement to the platform, to be able to store it, to be able to process it, to access it, and of course also to algorithms, to be able to process that data in the algorithms. And this results around around 7 terabytes of data per day, and is a technical challenge. The next technical challenge is on the velocity, so that means it's about streaming data and how much data comes into a system at one point in time. And what we saw is that often we have milliseconds intervals when the data is recorded. And often customers ask, oh, how often should I record my data, especially at the beginning of an IoT project? What is your experience? And of course, as data scientists, you say, everything, because you might miss something. But it's really a challenge. Also, vibration data we see often in industrial scenarios where you look at, for instance, a bearing and you have a sensor on it which measures vibration, and that's often a lot of data which comes in very short cycles. Another one which is not only a technical challenge and it's more a challenge also for data science is variety. So the different types of data, and we see all of this. So especially time series, of course. Sensors are sending time series. You have a timestamp, you have a value, and you have many of them. We see more often now images and videos. So for instance, we had a project with a car manufacturer, a German car manufacturer, on actually the door manufacturing. And they had thermal images, so the heat distribution in the door, and they wanted to recognize problems, quality problems, with these images. That's what we did. So more these industrial use cases. But for smart city, for instance, I think videos are normal, surveillance videos and so on. So all of that is there and is coming more and more. Text was always a topic already 7 years ago when I started at SAP, and I think it will always be. So it's about detecting topics. For instance, in industrial cases, in a set of warranty claims or repair reports, what kind of problems do people report? So the technicians or the customer, the user. And then you want to show what is upcoming. What are the problems which are upcoming, which are growing over time also, the number of how often they are reported. And then we have normal relational business data. What I mean with that is when did the car has been manufactured, where, in which factory, in which country, things like that. More kind of master data of the thing or the machine, but also master data on the customer, on the supplier. Very important. If you look at quality, look at the supplier. And to be honest, also look at who worked on that line on that day. It's very difficult in Germany because of data privacy and so on, but it's often a factor why a specific quality problem occurred on a specific day. And then one of the most challenging problems for us as data scientists is this veracity or uncertainty. So usually you have the problem that you have poor data quality, really. We never, ever had a project where we didn't have that problem. It's just normal. And I remember my research times where that was not a topic at all. I had these public data sets, and I could work on it. Just start with the modeling, with the algorithms, with tuning, all of this. This is not reality in practice. It's really different. It's completely different. This is where 80% of the time in a project goes to by the data scientists. Missing data. And what we saw often is that the data was not collected for this purpose, for fulfilling or solving a specific use case. It was collected because of legal reasons, because of some other reasons, and it was never meant to be used together. Never. So our problem is often, if you look at these different data sources, how do we bring them together? Because usually by time. I mean, you have time series. You have to know, okay, when was the time series of a specific asset we call or machine recorded? When was the image recorded, and so on. But often the problem is that there are different clocks, system clocks. A very trivial problem, but very hard to solve. So that means the sensor reading comes from a specific part of the machine or two machines, and now you want to look at them and need to know which time is the correct one. Because if you don't know that, your model will be terrible. It doesn't fit together. Or on the maintenance notification, so say in the airplane, the pilots are recording problems after the flight, right after the flight. Very good. You know, they record everything in the system, we have it. But there are other types of problems which are recorded later by the maintenance technicians. But we don't know when. We cannot identify the point in time where the failure really occurred. It's very hard. And that means you have a lot of uncertainty in your models, unfortunately, because of this. But my main question today here is how to extract value. Because as before, I do not believe that it's really that data is valuable per se. Many say data is the new oil, the new gold, and so on. Of course, you have to collect it. If not, you cannot extract value of it. But without extracting the value, without doing something meaningful with that, it's not valuable. So what to do? Yeah, I think that machine learning can help. Also, it's not easy, as I just emphasized for some points. And let's look at how and what exactly it brings, what our customers say, what they expect, and what it could provide. So the first thing is transparency. Very easy, and actually also very trivial. But customers often do not know their data. They collect it, but they never look at it. They do not have the tools to do it. It's too much data. So that means the first thing we do in a project is more kind of reporting with nice graphs and so on. And often already you see something in it, and they say, oh, I didn't know that this has happened in the past, or that this was the reason for something. So it's already quite interesting for them to see just pure statistics. Then what we see very often, and at the beginning I didn't believe that this is real, or I thought it's a hype. Everybody says they want new business models, but I talked to many customers, and their expectation is to really use this new data to create new revenue streams. And for instance, one of our customers, it is actually producing big machines, and he was always producing that, but now they are compressors. Now they are selling compressed air. So their business model changed completely, and it's true. That means the customers do not buy the compressor, but they get it where they need it, and they are paying per use. So it's the pay per use model. And we see that not only for the compressors, for different bigger machines, that you actually pay per use, but also often in some markets there is a lot of competition, and the customers look at what could help us being a bit better than our competitor. And it's about providing additional services like some portals or dashboards where the customers can see their data or get predictions better. So getting additional values from software which our customers provide to their customers. We see that a lot. Customer portals is called for their area. Proactivity. So customers do not want, as in the past, then just react on a big problem and then afterwards think, what was the problem, why did it happen, and so on. They want to have some kind of trends, predictions, and so on. And even better is really optimizing a whole process, increasing productivity. And in the end, for many areas, they actually want automation or semi-automation. But I think for some areas, it's really far in the future to achieve that. And maybe not always also feasible. I don't go into this, but because I think all of you know what is data science, what is machine learning, what is AI. I have it only here. You know there is a big overlap, and some even say it's the same, it's all the same. But what I want to emphasize also, because there is a big hype in deep learning. And what I have seen in projects is that deep learning in IoT now does not work yet. Because you see, this kind of pictures is very easy to recognize by deep learning, and the reason why this is the case is because there is a lot of data. That means you have millions of examples with labels, so you know this is something about a landscape, the sea, vacation, and so on. There is no person. It's quite easy, and deep learning is very good at doing that. Also for translation, machine translation, there's a lot of text around in the web. And the Google Translate, that's a picture from there, is really good already in for many languages to doing that. But the problem is that in IoT, you do not have, even in pictures, so where is the picture? It's not here. Okay, something went wrong with that. There was a bearing. So if you look up bearings in Google, broken bearings or a bearing with a crack, you find much less results than for landscape. It's normal. It's not yet used a lot. It's not. People do not take pictures of broken bearings a lot in the factories. The data is not there. And if you look at time series data, where we really have this, these 2 zettabytes of data, the problem is that the sensors are not standardized. So the formats are completely different. So each company has its own way of recording the data. It's messy anyway. So there is no chance to do that. So I have a PhD student in my team on this. So he's doing deep learning for the time series part, for anomaly detection, failure prediction, things like that. And okay, now 1 year is gone, but it's not working with the normal deep learning algorithms. So he's looking at now at completely new things to improve it, because until now it's not really working well. I wanted to distinguish different classes of machine learning based on the complexity and automation level. And because we see that a lot, and I mentioned some of this earlier. So descriptive, what has happened in the past, is really the basic, which you should do with customers, because it's good. It brings transparency. It does not help in automation, but it brings transparency. Diagnostic is about to know why something has happened. Of course, it's not about causation. It's correlation. As you all know, there is this difference. Most algorithms give you only correlation. It's okay. That means still the customer or the user has to look at it and make up his mind. Is that causation, correlation? It needs to look at and really check it in reality, what it means. It gives an indication. It can help. Predictive is what we are trying, which is not simple for some use cases. I will come to that. It's really hard. I mean, in general, predicting the future is not simple. But for some areas, it's harder. And prescriptive is actually what we really want to do. So we want to really recommend what the user should do. For instance, in the area of Industry 4.0, technicians could get a recommendation which spare parts to take with them when they want to repair a specific component or a machine, which tools to take there, because going again there because you missed out a specific tool or spare parts is very expensive. So that's what we want, to really give recommendations. But if you look at the competition in this field, there's not much yet. So that's a field where one can go, prescriptive analytics. I want to show you some use cases we looked at and we approached with machine learning. So it is mainly also about anomaly detection, and I will tell you later why. And we saw before in the talk as well, anomaly detection for traffic analysis. So that means you learn the normal behavior of a healthy machine. You have a lot of data of that. That's not a big problem. Sometimes you need to talk to the domain expert. What does healthy mean? Is this period of time a time where it is healthy or not? But this is easy. So you can learn the normal behavior and then apply the model to new incoming data and detect deviations from normal behavior. That's quite fine. Other things is more on classical classification, but more on images here. Classify different assets, we call machines, to which categories they belong. So it's a lot about similarity search as well. So actually the use case is in for instance, an asset network where different producers, suppliers, and consumers or buyers are coming together. They want to search for a specific type of machines, and you can do that when you classified before and you know what kind of a machine it is. There are specific standards, classification standards, which you can use and then apply to those who are not classified. But also on the connected car part, it is about recognizing what kind of trip you are doing. Where do you drive with your car, and why do you drive there? Is it a business trip? Is it something about leisure? Some regular trips to work? And the reason why we are doing that is to offer additional services when we know what you're doing. That's one reason. Then the actual goal in predictive maintenance, where you want to say when failures will occur and so on, and send somebody there to the site very early, is predicting the failure. And based on machine data, so sensor data, and historical failure data. So for instance, service notifications, warranty claims, so you correlate both of them, and it's about supervised learning. For anomaly detection, we use unsupervised learning. We do not need to know about the failures from the past, which is easier. Another one is more on forecasting, for instance, the yield of a plant or the output of a plant, so that you can plan better in the future, but also about the expected process time. So all about different forecasting use cases for improving productivity, for optimizing productivity. Then more on this diagnostic analytics, so root cause analysis, supporting root cause analysis. It's a lot about decision trees, about association rule mining, where you just use the past data and want to tell the customer something about the data and what has happened in the past and maybe why. And the last one I mentioned, it's really about this recommendation of next steps, really action. What should I do? If I look at the dashboard and just get information, it might not always help me. For instance, at the moment we are displaying an anomaly score for each asset. It's okay, but it's not what we actually want, or a probability of failure. It doesn't really help the technician or the end user. What we see as challenges for machine learning in this IoT area is the high-dimensional data, not only because of technical problems, but more which features should I use for a specific use case. If I have 40,000 or say 4,000 sensor data, it's not features yet, so you have to create features first. For instance, take the minimum, maximum, maybe some more complex things. Which should I use? It's really difficult because visually you cannot go through all data. It's just not possible. So what we did in the project is we really had almost always a domain expert, so an engineer who knew this machine completely. And he often helped us with, look at this, and explained how it actually works, and what is the relation from the different sensors, because we as data scientists, we don't know. Now we know some, but not in detail. Or, of course, you can also take automatic feature selection techniques. We sometimes did, but we still felt that the domain expert could help better. Then another one, which I already mentioned, data quality is poor. I don't have an answer to that. Tools can help, I think, good tools who automate some detection of the poor quality so that you do not spend so much time in searching for this and finding all the data quality problems and fixing them. But this is, for me, still an open problem. Then what is specific to this IoT area when you want to predict failures or rare events, there you can't use normal standard machine learning algorithms because you will result in poor quality. The models are not robust. You cannot use a decision tree for a data set where you have less than 1% of positive cases, so failures. So that means you have to look at other things. There are specific things for imbalanced classes, which you can look at. We do. We look a lot at ensembles. So maybe you have heard about boosted trees. XGBoost is winning most of the Kaggle challenges, or at least did last year. So we are looking at ensemble learning, which is a bit better than the standard algorithms. Another one is that you have either very rare events, so just a few labels, or even bad quality labels. We had that a lot because the human factor comes into play. If you have to record a failure in a system, many do that very, very badly because it's not fun to type in a SAP system, had a failure on this machine, and so on. So usually the quality is really bad. Of this. So often we said we just disregard all the labels, really, because you can't use them. So we said we focus on unsupervised learning with, for instance, anomaly detection. Another one is that we saw different industries, different customers, and most had very different use cases. And what we decided is then for the system we built, we need extensibility, we need flexibility. So that means users from the customers can come, data scientists at the customer can come and integrate their own algorithm. Maybe a very specific algorithm for a specific type of machine or component which we just do not offer. So that's more a technical requirement to platforms. And the last one is also more a technical one, deployment challenge. What I mean is, if you do a project, or also in research, you do a one-time analysis, and then that's it. You evaluate, you have your quality measures, you can show, yes, it works, I can publish a paper. And that's it. But in reality, you have to bring these models into production, we call it. That means they have to be applied every day or every hour or in real time. We don't do real time at the moment, but more scheduling. So every hour, every day. You have to have this functionality of scheduling, applying this. Also on retraining the models after a while. All this, we call that model management. That's what you need. And you need this kind of deployment and model management capabilities. I put down the process which we experience in the projects. It is what I already mentioned, all this pre-processing, cleansing, exploration, which you probably know. It's around 80%, 70 to 80% of the time we spend. Then you could learn a specific there is something, learn a model, either a prediction model or an anomaly detection model. But what we also saw and what we think is important, and we are working on it now, is to integrate the feedback of the user. So if you have a lot of false alarms, for instance, from an anomaly detection model, which happens, they can say, no, it's not an anomaly, or it's not an interesting anomaly. It's not interesting to me. There, even personalization could come in for specific roles in the company. So one is more interested in a specific type of failures, another one in another one. And we think this is very important also for supervised learning, because you are collecting more labels if you ask for feedback. And here, active learning is a topic which we are looking at. Then you predict. I switched it. Yeah, the order is not correct. We predict the failures or anomalies. We give failure probabilities. We give remaining useful life. So we extrapolate and say how many days or hours or months the asset machine will still work fine. And then what we have a prototype on, but is not available, is this recommendation piece, where we want to recommend what to do, which spare parts to take, which tools. And then somebody has to act. It's not us. So you either take the recommendation or you say, no, this doesn't fit. And of course, here you should also have a loop of feedback. Again, did this make sense or not? So this is actually, really from the product, a picture. It's at the moment predictive maintenance, and it has exactly what I have said. The extensibility, the anomaly detection, the failure prediction. We call it adaptive learning using domain expert feedback is not yet there, and the model manager we have, and the prescriptive we are working on. I have a very concrete use case from a project in a chemical plant we have done. And I have different use cases which we looked at in 3 projects. So we had with this customer 3 projects to different use cases. And the typical one we usually do is the maintenance use case. So we want to predict when the next maintenance should be done and so on. Or if you have regular maintenance, say, don't do the regular maintenance now because your asset is completely fine. So we are good at predicting the negatives. True negative score is very high. So it's very easy to say, don't do maintenance now. Usually, depending on the use case, you do it, say, every 10,000 kilometers, or every, for other production lines, I know every 2 weeks. They just do it, but they don't have to do it. They actually could save a lot of money by just not doing it. So we are looking at that. Process improvement was here the case which I will show. So that means it's about the process time. How quickly can you finish your process? And in the chemical industry, it is about creating products, chemicals. And, but other use cases were sustainability. So especially in chemical plants, they have the problem, what should they do with waste? It's really a problem with the environment and so on. So we had use cases there to minimize waste. And others are more on the product quality, where the suppliers come in. The suppliers of the ingredients of the chemicals, who has sent it when and so on. What is the root cause? Maybe that this specific batch was not good and so on. So more root cause analysis in this area. But focusing on the process improvement is, so here the use case was you had 2 ingredients to produce some chemical. And this worked in the way that both ingredients should react completely. So at the end of the process, nothing of the input ingredients should have been there. So that's the process. And we wanted to minimize the process time. And usually what they did is they took samples from this process quite often, send it to the laboratory, checking whether these ingredients were completely away, so they reacted completely, and then continued or stopped the process. It's cooking, it's really about cooking the chemicals. They call it like that. And what we did is we actually applied anomaly detection there. So we learned what is a good batch and how long did it take. And then when an abnormal batch, so where the chemical reaction was not complete, came in, we said, yes, please send now to the laboratory. But we also said the others, they should not send. So they sent much too many of them to the laboratory. And that's why here we could save 25% of their laboratory cost, and they were faster because they didn't need to wait always for the results. Good. Coming to my last part. What is the future of IoT and how can we make it happen? Maybe even you. And actually, that's my ask, that you should help. We have heard about personalization also before in the talk, and I think really that this can help personalization. So especially in the consumer market, machine learning can help to have personalization. And we saw these different use cases from the consumer market, and I put some examples together of what could be done. For instance, energy saving recommendations in your home. I don't have that, unfortunately, in my smart home. I think it's not on the market yet. But it could be useful to know, how can I save? Which are my main machines in my household would contribute most to the energy consumption. And also more personalized, that the system knows my normal behavior, and also what will come up, whether I will consume more or less, because maybe some family event, I have a big party, or I don't know, then it should adjust to that and not tell me, oh, don't consume, because I have to consume, right? I have a big party, I can't avoid it. So really intelligently do recommendations here. Then the digital medical assistant, I really think this is actually something which could help the whole humanity if we had a better medical system in general. So that means either the doctor has a digital assistant which can help by looking at the patient's data. So it's about the medical record, but also at the sensory input from different devices and so on. At, of course, others, similar patients' data, but also at medical databases where you have a lot of symptoms and what does it mean, because I think most doctors cannot memorize all of these things. Actually, this doctor told me that it's difficult. So he can only memorize what he often sees. If there is something rarely happening, he just doesn't know. Then where to park. This is, I think, really already coming. Yesterday I found some app or a company who is doing this. So it's about learning doing recommendation on where you should park your car based on the sensory information. So there is in the ground, there are sensors already in some places put in the ground where you can sense that there is a car or not, so that you know how many places, free places do you have. But I would actually even want to go a bit further and look at historical data. Where did you park your car? Where do you live? And what is the area? What is the traffic around? And so on. More data to really do a good recommendation. And then more on these fitness trackers. Really have a workout plan based on my health state, my calendar. Do I have time? When do I have time? So putting more things together here. What do we need to do so that this can happen, so that we can integrate more machine learning here? And what I see as a very important point is really creating trust, because I see at customers or also in my private life many people who say, no, I cannot trust in that. So it's about security, especially in IoT area. Everybody, at different conferences ask, but what about security? And I think it's really a topic. And I mean, it's not my topic, I'm a data scientist, but it has to be done, security. Then the ethical standards. So especially also in the medical area, and especially here in Europe and in Germany, data privacy is a big topic. If there are no real standards, what is allowed and what not, People will not trust. And on the other side, more on the user interface design, I think you can also do a lot, and we look at that. So how do we present the results of machine learning and IoT to the end user? Do we explain what we did? This helps a lot. They want to drill down. So if I say the score is X, Y, Z, that's not enough. They need to have the possibility to analyze themselves and then gain trust into these results. So they have to drill down, they have to get the reasoning, where does this score come from, and so on. Another one is more on this algorithm part. Maybe there are some data scientists here, I'm sure. It's really interesting to work with this IoT data, and there are a lot of challenges one can look at still from the research point of view. That's why I have a PhD student in the team, and we'll have another one. But here, if you have the interest, please go into this domain, look at what is there and what can be done. And the other one is more on the system side. So we need really simpler system where you can develop IoT apps. It's still quite, every company has different standards and different, also in software, what you do, what is the data model, and so on. So that's more something to the software companies, so to ourselves also. And the last one, which I think also this community could help, is on how can we capture the knowledge. It's a lot about also semantic web technologies. How can we build ontologies for different areas in the IoT space? How can we help standardizing that by using these technologies? It's also about capturing the domain knowledge. So I felt in many projects this helped most, having the domain knowledge in. And we don't have that in IoT at the moment, at all. So that means, for me, bringing three worlds together is important. And the three worlds are machine learning, as I said. It is something called physical models. And that's actually the technical knowledge, the technical domain knowledge. There are mathematical models, equations, where you can write down how a specific engine works and so on. But these worlds do not work together. So machine learning and the physical models, there are not many things which look at each other and do a hybrid model out of that. So that's one. And then the other one is the semantic web, where we could come up with a good data representation with ontologies which are capturing some of this knowledge. So that's my vision, and I think maybe on the semantic web of things, I think there are a lot of experts here as well who could look at that. So that's it from my side. The picture is also missing here. So I have, if you want to read more on the technical side and what is offered by my team, there is a white paper where the picture is missing. So you can Google the title, Data Science and Machine Learning in Internet of Things and Predictive Maintenance, or later I put the slides on SlideShare, and you can click the link to find out more.
That's much more comfortable. Yeah. So thank you very much.
Yeah,
Preisach.
Do we have time for questions?
We have a couple of minutes, not too many, but we do have a couple of minutes. So we do have a question back there. I'm coming.
Hi, so thank you for the very interesting talk. You mentioned that just towards the end, one of your key challenges was providing explanations of the outputs of ML to your end users and to the other people in your organization. Like presently, when you provide an explanation, what does that look like? And do you have a vision of what these explanations really should look like for them to be useful and usable and to build that trust?
Yeah, we have a designer in my team. So we're talking a lot about that, what can be done? And at the moment, we are thinking about a lot of visualization, so more visual input. So for instance, if you have a score, you click on it, and you get all the input sensors or features which were used, so that you can detect patterns. That's the first very a simple step. So more because engineers are used to look at graphs as well, and they know, for instance, if a specific value of a sensor is higher than something, and this other one as well, then they have that in mind. We talked often to them. So we try to show patterns, or at least the data. But my designer has more wild ideas. We are not at that stage yet to say, okay, we do that. But we try already to have more visual, not just numbers. And then recommendations. And so say if you use rules or association rules or decision trees to visualize that, visualize rules. It's much easier for a human to perceive than just a number.
Hi. My question is, you mentioned about rare events, which I cannot agree with you more. Would you elaborate a little bit more on your solutions on that issue?
There are two solutions for us, or what we decided is. One is to not do it. That's one. That means instead of predicting the failure, look at anomalies. Do anomaly detection. Of course, anomaly detection means that an expert has to look at the result and say, is it really an anomaly? Is it really leading to a failure? So it's more manual work for the expert. But maybe it's more accurate in that sense. Of course, we can't say it's really a failure, but it is an anomaly. We are quite sure it is an anomaly, but maybe it's not interesting. Or maybe it's just showing that the sensor is broken, which for some use cases is useful, and for others it's not, because sensors are so cheap, and many do not care, is it broken or not, you know. And the other one, so it's ensemble learning. So we are looking a lot at ensemble learning. Ensemble learning. Yes, learning many models and then getting better results. And we got better results, but we're still in the phase where we are trying and applying to more data sets.
Yeah, thank you very much for your presentation. My question is, in your presentation, you mentioned several times that we need domain knowledge, the person who's in that area. But for us in academic research area, it is sometimes quite hard for us to get access to those people.
Yes.
So do you have any suggestions for us?
I think here we probably need a good cooperation to this Industry 4.0 or whatever companies, so really the manufacturing companies in a consortium, for instance, in a project, probably this is possible. And what we really said at the beginning of a project is, we do this project only if you guarantee an expert. But I don't know how this will really work in scientific projects, but we really said at the end.
Okay, maybe one last question from my, well, I spare my last question and hand the microphone to you.
Hi, my question is about how to capture learning, and if there is a standard way of doing it, and whether or not this can be related to ontologies. Mm-hmm. Because capturing learning, I mean, you programmers do it in coding, you do it in models, and someone else does it in a different way. But is there like a standardized way of doing it?
So I'm not sure. So as you said, we are doing it in models, and we are writing the results somewhere, and we are capturing the metadata of the models and the quality and so on, and all of that is also part of the explanation. But I don't have an answer to your question. So my hope is, since I'm not a semantic web expert, is exactly that. How can we do that? You know, also not only on the learning part, but also on the input side, you know, the knowledge about the devices, the sensors, and so on.
All right, so now my last question refers to the future of SAP, if you like. So my question would be, how much machine learning would we see in the standard products of SAP in 5 years?
I think a lot, because we invested a lot. Now there is a new department with hundreds of people, not all data scientists, but all working for data science products or functionalities. So I expect, I don't know, probably at least around 50 products having that.
Well, good luck with it.
Thank you.
And thank you very much again for your presentation, Christine Preisach.